Good morning, chemistry classes. This is Mr. Bennett. We got another lesson to do here. Before that, I wanted to remind you to please let other students know how you're contacting me through the Google Classroom, and because right now we only have about half the students participating, so hopefully we can get more as we go. And just do the best you can here. Another thing you can also do is Prager University's. Feel free to do those. And let's go ahead with our lesson on the ideal gas law. So here, this lesson will probably take, I'm thinking, about 10 or 15 minutes, so be patient. And at some point you may want to have a calculator out so you can go through these, and obviously what would be nice is you can pause as we go through this, so makes it easier and you can do it at your own pace. But so the ideal gas law is, and first of all, we've been using the other gas laws where we have PV over T equals PV over T. And now we're going to do something a little different. And this is when a quantity such as moles or masses in grams are used. And so that's called the ideal gas law. And let me show you that. Okay. Here we have the formula. It's PV equals nRT. You can just kind of remember that. That's how I remember it. PV equals nRT. And P is pressure, V is volume, N is the number of moles, R is a constant, T is the temperature. So be careful to make sure you get the units right on all of these. Pressure has to be in atmospheres, volume has to be in liters, moles is moles. Temperature has to be in Kelvin, and this constant R is always going to be 0.0821, and it's just a number, and it's a constant number, and it doesn't change. So you always, wherever you have R, just insert 0.0821. So when you set up these problems, the way I would recommend doing it is going ahead and putting PV and RT and just inserting all the numbers that you know. You're always going to know R, so you can just put that one in every time. And then just put in what you know. And then whatever you don't know, that's your unknown, and you'll solve for that unknown just like we've done with the other gas problems that we've done in the past. Basically, you're going to be isolating a variable. So let's do an example here. Now, what I would like to do is the example off of your Ideal Gas Law Basics worksheet. And I'm going to pick number 3. And I'm just going to put the numbers from here onto the paper like you would do. And so P in number 3 is 3 atmospheres. V is 52 liters. N is what we're looking for. R is 0.0821 like it always is. And the temperature in number 3 is 313. Come on, Bennett. 313 K. Okay, so now what you're going to do is just put the numbers into the formula. So we have PV equals nRT. So the numbers will be 352 equals N, which is what we're looking for, times 0.0821 times 313. Okay, so now we just need to isolate N. So when you isolate N, get N by itself, you're going to divide both sides by these two numbers, and you'll end up with 3 times 52 on this side. And on this side, you're going to end up with 0.0821 and 313. Okay, so now on your calculator, you'll just type in 3 times 52 equals, and then you're going to go divided by 0.0821 equals, divided by 313 equals, and you get 6.07. So I'll just round that off to 6.1. Okay, so it's N equals 6.1. And what's N? N is the number of moles. So that is the answer to number 3. Okay, so that's one example, and that would be one that's on your assignment. And then we'll do one more example. And here is the other one. So I just made this up. Suppose you have 36 grams of water, which is 2 moles of water, because water has the molar mass of 18. And suppose you have 32 grams of water, 2 moles of water, and it is existing as a water vapor at 20 degrees Celsius, and it's up at Lake Tahoe where the pressure is 0.8 atmospheres, lower than it is here at sea level. So you're just supposed to calculate the volume that that much water vapor would occupy. Okay? So if you're taking good notes, you would just copy this down as the problem. So you'll notice that all the quantities have been underlined, and this is the quantity we're looking for. So you're going to take these numbers and put them into a setup like this. And so we got P equals 0.8. V equals, we don't know. N equals 2 moles. This is atmospheres. R equals 0.0821. And 20 degrees Celsius plus 273 equals 293 Kelvin. Okay, so we have 4 knowns and 1 unknown. We'll solve for the unknown. So PV equals nRT. So we got 0.8 times V equals 2 times 0.0821 times 293. Okay, and then now we just need to isolate V. So we're going to go V equals, and we're going to divide both sides by 0.8 to get rid of the 0.8. We're going to have 2 times 0.0821, 293 over 0.8. Okay, and then I would take my calculator out, clear it, and you should get 2 times 0.0821 times 293 equals. And then you're going to divide that by 0.8, divided by 0.8 equals. And it's 60.1. So we'll just round off to 60. 60, and the volume in this case is always going to be in liters. So it's going to be 60 liters. So 60 liters of water vapor is the answer. So hopefully that will help you to do these problems. One question might come up is, what are the units on the R? And I don't really want to go into that right now. You can just use the R as a number. I think that'll make it simpler for everybody. So, alrighty, that ends the lesson, and good luck. If you have questions, send me your questions. Bye-bye.